Morning, everybody. I'm Jawad Rustai. I'm a postdoc at UNC Chapel Hill, and this work is with my advisor, Dr. McDonald Gibson. We are using Bayesian network modeling for environmental risk assessment and public health work. And my work is pretty applicational and is kind of involved with almost all people in this room and probably in the whole US. We have a chemical that we use for decades, and it's a group that called PFAS, and it has been used in different material, and almost everybody in different countries around the world are exposed to that. The Center of Disease Control has done a study for population and find PFAS material in the sampling for almost all people who attend that project. And this material is combination of 5,000, like 500 sample, and it's very complex to find them and to like analyze them and like to have a specific action for each of those. And after they dispose, like they ended up reaching to our water system, as you can see in this picture, a picture from different sources. And then we ended up consuming that as well. And those are really hard to decompose, and they usually bioaccumulate in our bodies. Because of that, we are trying to analyze and use machine learning because the problem is so big we cannot like use traditional, or we don't have that much source to go and use and sample every location in the US, for example. So we use machine learning to come up with some generalization and find those areas that are more at risk. And this is the sampling data in North Carolina, and the complexity of this like data is also showing here that we can have a very like high level of GenX, one of the PFAS material, and the neighborhood adjacent to that one has a good level. So it's kind of very complex that how is parameters are affecting different people's home and their water. So we have collected multiple data source to analyze for that problem, but it can be extended to any additional places. Like this is like a type of data we also collected, like home age, home like properties, education levels, and it came up to know to like 240 potential variables that may or may not have effect or predicting model. So it's something like that, and we try to go through this data set and see if we can predict or target goal, which is like the level of that parameters. And it's very complex, so we cannot like easily go through that unless we use machine learning and Bayesian network models. So we use that to cluster the data and come up with some pattern among that, and then use that for procedure to predict the GenX in the water and in the wells. And this is a preliminary result of our model, and find out among those like 240 parameters, which parameters is in general is affecting the GenX in the region. And based on that, the models, it has like the ROC curve value of 86% up to now, and then we use the tenfold for accuracy measurement, and then we map those areas that are more at risk. We can go and then focus on that specific location that has more risk if we want to do remediation. And this model also like show that what's the pattern of for this location, for example. So it's coming from a chemical factories, go through the rain, go through the soil, and reach to the water. So it's kind of confirm the result. And then we also have like this front-end web page application for users, so they can put their data set, for example, and then they can have a predicted value for their level of GenX, if they are at risk or not. So this is one example, but environmental engineering, public health related issues, or civil engineering, it has tons of these problems that is rarely touched by machine learning and AI. So it's a vast area for research, and I would invite you to join my poster here, and this is the source. And thank you.